Next I am discussing refraction through a glass slab. Here air glass medium is a glass slab and this is air. So here an incident ray. So first we have to draw a normal to show the incident ray. So this is the incident ray. This is the incident ray. And this is the angle of incidence. So when the ray incident on the glass surface, it is entering into another medium, that is glass. And in glass, the speed of light is 2.25 multiplied by 10 to the power 8. So the path of the light gets deviated. The speed of light will be less because glass is denser and air is rarer. So when light travels from a rarer medium to denser medium, its path gets deviated and it moves towards the normal. So the ray will move towards the normal. The ray will move towards the normal. So this is the refracted ray. This is the refracted ray. So here the ray refracted and again the ray is entering into air. So here you have to draw the normal. Here you have to draw the normal. And the ray is moving from glass to air. Air is rarer. Glass is denser. So when a ray of light moves from a denser medium to a rarer medium, the path of the light gets deviated and it moves away from the normal. It is moving away from the normal. It is moving away from the normal. This is known as emergent ray. This is the angle of emergence. So this is the angle of incidence. This is the angle of refraction. This is the angle of emergence. So if you extend this ray, if there was no refraction, the ray will pass like this. And this is known as lateral shift. This is known as lateral shift. So if there was no refraction, the ray will pass like this. And this is the emergent ray. This is the dotted line. The distance between, the separation between them is known as lateral shift. So this is the incident ray, this is the refracted ray, and this is the emergent ray. So when you draw refraction, you must draw the normal. So when the ray passes from air to glass, the ray refracted towards the normal. And when the ray passes from glass to air, it will move away from the normal. So here the angle of incidence will be equal to angle of emergence. Angle of incidence is equal to angle of emergence. So here there are three angles, that is angle of incidence, angle of refraction, and angle of emergence. And three types of rays are here: incident ray, refracted ray, and emergent ray. So this is the refraction through a glass slab. V equal to C by N. C is the speed of light in vacuum or air. The speed of light in vacuum is 3 multiplied by 10 to the power 8 meter per second. Or V is inversely proportional to refractive index. Greater the value of refractive index, lesser will be the speed of light. Lesser will be the speed of light and the medium becomes denser. Lesser the value of refractive index, greater will be the speed of light and the medium becomes rarer. So V is inversely proportional to refractive index. When the speed is more, refractive index will be less. If the refractive index is more, lesser the speed of light and the medium will be denser. Lesser the value of n, greater the value of speed of light, and that medium will be rarer. In this diagram, the ray passes through the normal, or the ray is normal to the surface. This is medium 1 and this is medium 2. Here the angle of incidence is 0. What is the reason? The angle between the incident ray and the normal is 0. If the angle of incidence is 0, the angle of refraction also will be 0. And the ray will be undeviated. That means there will be no refraction of light. That means there will be no bending of light, or there will be no deviation of light from the rectilinear path. So when the ray incident on the surface at 90 degree to the surface, and the ray passes through the medium without any deviation, or the ray enter to the second medium without any deviation from the original path. So this is medium 1 and medium 2. Here the angle of incidence is 0, angle of refraction also will be 0.